हम अपने नेक्स्ट की नोट स्पीच के लिए मैं दावत दूंगा मुनाफ अहमद साहब को, डायरेक्टर हवावे। उनसे गुजारिश है कि तशरीफ़ लाएं और अपने ख़यालात का इजहार करें। मुनाफ अहमद साहब।
I'm Munaf Ahmed, Director Solutions, Huawei, Pakistan. It's a great honor for me today to have the opportunity to share with you some of the latest technology innovations that are being used in the financial services industry with you today. The topic of my presentation is Intelligent Financial Network, Reshaping AI-Powered Connectivity for Smarter Finance. We are now moving into a banking era called Bank 5.0. Before it was Bank 4.0, which was digital banking. In Bank 5.0, we are looking at the infrastructure, getting the network infrastructure, using more advanced technologies like AI and IoT to further streamline and customized users' experience. The topic, so for example, ICBC, which is one of the largest global bank, it has started using AI-based assets, probes, to AI models that boost basically the smart customer engagement to up to 98%. This is from ICBC's website. Similarly, China Merchant Bank, they moved over 100 million plus customer accounts to the cloud and have achieved cloud service availability of 5 nines. Again, these are some examples of how innovative technology is being used to help customers achieve improve their customer experience and customer services. So as we see, also we are seeing that before you had an active passive data center architecture, then the banks, they moved to a 2+1 data center where they have 2 data centers in a city and DR is in the 3rd city. Now this model is changing. The banks are using multi-site, multi-data center approach, which brings its own challenges in terms of resiliency and availability of your services. So we'll talk about how AI is going to address these challenges, especially when the RTO, for example, which used to be several hours, now due to compliance and regulatory requirements and customer expectations, then banks are moving to an RTO of under 30 minutes. And using human manual intervention when there's an issue in the bank, in the data center, achieving that kind of RTO is not possible. We are also seeing another challenge that we see is the network scale. Some of the banks in the last 5 years, the number of network elements in their data center, they have increased from 3,000 to 30,000. Managing such a huge network manually, it's not possible. It's becoming very challenging. And then there's the complexity of having a hypercloud architecture where you have different applications and you have to roll out new applications. How do you manage such a complex configuration? So all these challenges, we can see how AI can address these challenges. So like I mentioned, again, manpower is not able to handle the scale of the growth, the slow response for service recovery, and also the third thing is the security coverage. As you introduce IoT devices, the number of terminals increases exponentially, and that increases your threat landscape is increased. And how do you manage your cybersecurity? Because if you have any exposure, I mean, the threat vector also increases. And also more and more traffic is getting encrypted. The applications are getting encrypted. So it means you have to have some technologies that can look into this encrypted traffic without decrypting it. Because when you decrypt a traffic, that means there's some latency. So to avoid that latency, you can use AI technology to analyze encrypted traffic and be able to detect malwares in that traffic. So when we talk about intelligent network, we are basically addressing 5 long-standing issues. The first one is the heavy workload, which is caused by the, on average, the IT is handling thousands of service tickets. And this is a lot of time consuming. On average, it takes like 30 minutes to manually solve that ticket. So how do we fine tune this? How do we improve that thing? The other is the service interruption and restoration, because if there's an issue in the data center, how much time it takes to move to the services to, or the users to the other data center. Typically, the banks have a couple of hours of RTO, and like I said before, the regulatory requirements that the banks are facing is to bring that RTO down to under 5 minutes. Then the low efficiency of troubleshooting. When there's an issue in the network, obviously there's a manual interaction, manual debugging has to be done. So that takes, again, time to fix those, and typically it's more than 30 minutes. And like I said about the high security risks of massive assets, like there are some banks that have over 5 million assets and globally across the globe. Now, how do you manage those, make sure all the assets that are connected to your network are identified and properly managed and configured? Because any unmanaged assets is a potential backdoor for the hackers for attack on your network. And the fifth thing using AI is to improve the user's experience that users have using their applications, for example, video conferencing or real-time applications that are hard to debug in real time. So these are the 5 challenges that the AI-based smart financial network addresses them and solves them using AI technology. So let's talk about, so the first one is AI plus automation. Now, by doing northbound and southbound automation, we know that we can, some of the, okay, first, basically, there's a, we can automate the process, we can make the agile service rollout more efficient, and we can do the configurations and the policy changes on the network within minutes. That typically used to take days or hours or weeks. So that means you can roll out new services at T+0. And all this integration is out of the box. Like the controller is fully integrated, for example, with ITSM systems. It's also fully integrated with your network, and security managers doing complete automation of your network and your security. So by, again, using AI, we are able to reduce this time. The second one is AI plus improving the resiliency of your data centers. Now, typically, when it happens is, when you expand your data center to multi-site, multi-data center architecture, then it's, for the O&M teams, it's very difficult to manage such a large-scale data center deployments. When there's a problem, when there's an issue, it becomes very time-consuming and cumbersome. Now, by using AI, we can reduce this time. For example, if you have a multi-site data center and there's an issue, you're using a global server load balancer. Now, there's a manual intervention required on the global server load balancer to move the user traffic from your problem data center to your working data center. And by integrating your network, your data center with the global server network load balancer, we can reduce this time. I mean, we can share not only the application experience, the application health, the application quality, transmission quality. We can also share parameters like the network health, the network transmission quality, so forth, in real time to the GSLB, which can then react to any issues and be able to move the user traffic transparently in real time without any delays. So that with that kind of technology, you can achieve like an RTO of under 5 minutes. So The fourth one is AI plus O&M. And this is one of the area where there's a lot of R&D is happening. Is obviously human-centric. O&M is very inefficient. I mean, when there's an issue, it takes a lot of time. But what we change this to an AI-centric based that can handle over 90% of network issues on its own. So what we have is this solution called Netmaster, which uses a LLM-based network AI agent, the large language model network AI agent, along with DeepSeek and Qwen technologies. And it's able to understand, learn the customer network, because every bank has its own network, its own applications, its own systems running. So it learns over time automatically. It has a self-learning process. It learns the network and it develops its database. And it's able to understand complex language structures or sentences, break it down into network tasks, and automatically do the network configuration. Also, since it develops its knowledge base, it's also able to identify the problems and fix those problems without any human intervention. So close to 90% of the, over time, as it learns the network, over time it can handle over 90% of network problems and fix them on its own without any user intervention. So that means your O&M becomes really efficient and you're able to minimize your downtime. Right? So the next one is AI plus security. Obviously, there's a lot of other OEMs also working in this space where they're trying to automate your cybersecurity because manual configurations, there's always the possibility of human error, of misconfigurations and things like that. And because hackers can exploit that. So using AI to not only to integrate with all your security sensors, be it EDR, be it your NAC solution, be it your web gateway or email security solution, it can analyze your configurations, make recommendations, automatically configure them, push the policies, and also using AI, you can have an analytics tool that uses big data, machine learning, and AI engines to analyze the flows using logs like syslogs, logs from the syslogs, logs from the firewalls, and be able to correlate and detect any malware within encrypted traffic also without decrypting. So that really improves your SOC operations because it can react very fastly and also generate, if it detects any issues, any malware, it can quarantine or isolate that problem device or desktop or whatever the user is, and also remediate whatever the issue is, and maybe deploy some new policies or configure some new parameters on your cybersecurity elements, and in that way it can isolate that problem and fix that problem in a very fast way. And also, in case it's a day zero type attack, it can then completely take that user off the network or the device off the network so that there's no lateral movement of that attack. So these were the 5 areas. The last one is obviously is the user experience. One of the large bank, on average, it has close to 10,000 video conferences a month. And one of the biggest issue that the IT has is video freeze. And the issue with video freeze is it cannot be reproduced. It happens, and it can happen anywhere. It can happen in the Wi-Fi network. It can happen in the campus LAN. It can happen in the WAN, in your WAN network. So it's not able, you cannot reproduce it, and since you cannot reproduce it, it's very difficult to troubleshoot. So with AI, you can have a real-time analysis of your video flows that are going through your network, and it's able to pinpoint, in case of any video freeze, it can pinpoint the cause of it and also make recommendations or fix that issue in real time. Again, requiring no user intervention. The objective is to minimize the downtime of the network or the issues, to reduce them and eliminate those issues using AI. Another example is where we are using AI technology is Wi-Fi. Wi-Fi uses air as a media, so it's a potential for eavesdropping. I mean, hackers can use air sniffer and capture the user data and easily, hack your network. So what we use is we use a technology called Wi-Fi Shield, where it intelligently directs the signal, the Wi-Fi signal, to the user within 6 centimeters of the user, and anything around it is all noise. So when somebody tries to use a sniffer to capture, all they get is noise. They cannot get the data. There's nothing you have to do on the user side. There's zero configuration, and this thing is automatically done by the AP. Another example is assets that you have, the online users connecting in to your network using different devices, IoT devices. How do you identify the device? Now, the traditional method of what we call profiling is it uses a known fingerprint database. So it has a database that has the fingerprints of these devices, and it captures the fingerprint of that device that gets connected to your network and compares it with known database, and if it finds a match, then it can apply the policies. Now, the issue with that is using this method, the efficiency is almost 70%. It's not 100%. But using AI asset probes that are embedded in your campus LAN switches, in your Wi-Fi terminals, APs, you can identify the assets that are connecting to your network dynamically, and your identification rate can go over 95%. So you can have a better identification of what the assets are connecting, how they are connecting to your network, where they are connecting. All that information, you can get it from using AI technology. So that way, obviously, an unmanaged or not properly unconfigured or improperly configured device is a potential backdoor for a cybersecurity attack. So you can minimize the potential backdoors and improve your cybersecurity posture. So these are some examples of how we use AI. Since I'm in Huawei, so I have to use one of the slides to show the product line, but Huawei has been very actively engaged with some of the leading banks in China to implement this. We have real-life implementations. Some of the banks have already deployed this technology in their networks. Bank of Communication China, which is BOCOM, they have deployed this. You have this network agent, AI agent, which is NetMaster. It is LLM-based agent, and it integrates with your controller, which also, by the way, creates a network digital map. It's a 7-dimensional 3D map of your network. And then it has the complete visibility, and you can just give commands, verbal commands, or you can just type some commands, sentences, English sentences. It can understand what you want to do, and it can auto-generate the configurations, do the configurations. Also, if there's any issues, it can go in and rectify those issues. All the chips, all the products, be it the data center, be it the WAN, be it the campus LAN, they all have embedded AI chips in the hardware. And these AI chips are Huawei's own developed. They developed their own. These are not NVIDIA chips. They are Huawei Ascent series chipsets that Huawei developed itself. So they use these dedicated hardware to do the AI processing in these different devices. And then we have, obviously, the AI-based analytics tool, behavioral analytics tool, HiSec, which also can integrate with the EDR, your NAC solution. If you are going for a ZTNA architecture, we also provide that. And then based on having a full 360 coverage from the network's perspective, the end-to-end, the whole network is AI-driven. You have automated O&M, you have automated resiliency in case of any issues. It's a self-healing network. So this is where the technology is going. This is real now. Some of the customers have implemented outside Pakistan, but this is what we call Bank 5.0, where the technology is moving in this direction. There are also other OEMs also working aggressively. It's not just Huawei. They're also working on AI, because this is the next wave after cloud and digital banking. This is the next wave in the technology domain, where you introduce AI and you minimize the human interaction. Everything is driven by the AI. And even if the human interaction it's all more verbal in commands that you give, okay, do this, do that, in sentences, and the system is able to understand and break that complex scenario into specific tasks or network commands and execute those commands. The thing is, Huawei has been recognized as a leader in by Gartner in data center switching. They also have been recognized as a leader in wired and wireless infrastructure. So this is a big acknowledgement. Gartner is a US-based company, and Huawei has, because of geopolitical reasons, there's Huawei's complete ban in US, having zero footprint in US, but regardless of, even with zero footprint, Gartner is recognizing that Huawei as a leader. Again, this is a big acknowledgement from the industry. So that was my quick presentation. I hope you find it interesting. And if anybody wants to have a more discussion, we can take it offline. We can also have a deep dive workshops with you in case you guys are interested to learn further about it. So thank you so much. Thank you.